Alrighty, welcome back everyone. In this video we're going to talk about web application architecture. We're going to start off small with a simple setup and evolve it progressively throughout the entire video, so stay tuned. My name is Vasily Olenik, I'm a senior .NET developer, and on this channel we talk about topics and best practices related to software development with .NET Core. So if you like this kind of content, click the subscribe button and the notification bell down below. For additional training, check out vasilyolenic.com. So let's start off with the simplest setup that there is, and essentially we are gonna have a single web server where we are gonna deploy our web application. Of course, we will need to store our data somewhere. In our case, it's gonna be a database, and I assume this might be a SQL database since it's the most popular one. And the easiest way out is to deploy that database on the same web server. By the way, you shouldn't look from the high horse on this simple setup since it can get you going really fast, and for specific constraints, this might be a really valid solution that will get you really far without bankrupting your entire team. At the same time, holding the database on the same web server is not really the best decision, but it's a valid one for the time being. By the way, the database at some point might become a bottleneck, so adding some form of cache, be it memcached or Redis, to your web server and serving the data, the frequently accessed data from cache rather than having to do round trips to the database will improve the overall performance of your application. Now, the next thing that comes to mind when we talk about web applications is some form of file storage, since I have yet to work on a system that didn't require file storage. And more often than not, I'm gonna default to some cloud provider one, be it Azure File Storage or Blob Storage or Amazon S3 bucket. So our web application, the entire thing, is gonna communicate with this file storage, which is hosted somewhere in the cloud. Now, what can we do to improve our setup from here? The first thing that comes to mind is removing the database from the web server where we host our web application to a separate location, and essentially maybe even adding some form of replication to this database to increase the performance we can get from there. And the next thing is moving away the cache from the web server to another location. Let's say it might be another server that is more optimized, well, has more memory than our web application server, or to a cloud offered solution, let's say Azure Cache, etc. So our web application is gonna work with that specific cache in there and with the specific database. By the way, I have a couple of videos about how you can set up cache for your .NET Core applications using Redis. Since we talked about increasing the overall performance of our web application, we should also touch on the topic of scaling, and essentially horizontal or vertical scaling. Horizontal scaling is all about us having more instances of the web application. And by the way, this margin right now is no longer about a single web server, but rather just marking all our web applications in here. Essentially, you're gonna replicate your web application on different nodes to increase the, first of all, resiliency, also the availability of your application, as well as performance. By the way, you shouldn't really ignore also the vertical scaling. So vertical scaling is all about adding more juice to a specific web app server. And in the past, I've had some cases where vertical scaling made more sense than horizontal scaling for those specific constraints. Once we have more instances of our web application running, we will need to add a form of load balancer in here that will maintain a couple of rules. So the clients will communicate with the web application through the load balancer, which will redirect traffic to one of our instances for the web application. I'm gonna try to have the entire video as much technology agnostic as possible, but also send in a couple of links here and there to some topics that I've already covered, and down below you're gonna find a link to how you can set up a load balancer via .NET Core. And also, now that we talk about the load balancer, it needs to know how to route traffic and to which instances of our web application it can route the traffic, since, for example, one of our web applications might become unavailable. For these scenarios, your web application will have to add some form of health checks, and the easiest way out is to add an health check endpoint that the load balancer can call into to check the overall health of the instance itself. Additionally, you might decide to add over here some form of watchdog that you're going to deploy somewhere, and this watchdog will monitor your web application instances. And let me make it just white, and essentially send you notifications over some notification channel regarding the overall health status of your system. I've used in the past some form of watchdog that would send notifications over a Teams channel. Essentially, this notification channel might be Slack, emailing, or whatever your organization is using. By the way, the watchdog is not the only setup that can do that. We're going to cover some alternatives in a little bit. Now, once you have more than one application instance running, you will want to somehow ensure that the configurations are correct and that every application has a correct configuration. One way to do that is to add a config service somewhere where you're gonna store the configurations of your application. In the past, I've covered on this channel how you can use Spring Cloud Config, alternatives being Azure App Configuration Service or the Amazon or Google alternatives. So in this case, our web applications are gonna pull data from this config service essentially, and this config service is gonna talk to a config storage where it's gonna retrieve from the configurations. And once we update the configurations in there, we are sure that our changes will be propagated to all our web application instances. Since I've touched on the database part, you will also want to have a service where you are gonna store your secrets, since storing secrets in open is not really a good idea. So essentially, you're gonna have a config service and a secrets configuration service also. This secrets configuration might be Azure Key Vault, HashiCorp Key Vault, or the Amazon stuff or Google stuff in there. By the way, I'm dropping a little bit on the Amazon since I'm not really familiar with all of its services, since I've worked for 5 or 6 years already strictly with Azure services, and I'm still learning my way up over there. Now, with all this in place, let's talk about a thing that I cannot imagine our modern web applications without, and that is asynchronous processing. And the first one that I want to talk about is background jobs. In the past, I've used Hangfire extensively for setting up background jobs. Link in the description down below for a video on that. And Hangfire is gonna store its configurations inside a database, and then you can add background jobs to your web application that will run on a schedule. Essentially, based on your constraints, you might be fine running those background jobs if they're really lightweight on the web application. If not, you might want to add a processor somewhere. Essentially, a valid use case for this is if you have some hardcore background job that requires a lot of compute power, and we basically just deploy it separately from the web application so we don't impact the user experience over there. Now, cron jobs are one part of the asynchronous operations, and essentially the second one being working with a queue. So your web application might send a message to a specific queue, and that queue might be in-memory queue, or in our case, I'm gonna write over here one. Let's assume this might be a RabbitMQ queue. So essentially your web application is gonna post a message to this queue and have some other async processor pick up that message and do the job. This async processor, if it's lightweight, it can be incorporated to the web app. If it's really hardcore stuff, you can move it to a separate instance. By lightweight, I mean some integration with a third-party mailing service or of the sorts. And by hardcore, I mean some photo or video processing stuff that should be done in the background and is really time and resource consuming. Now, since I've mentioned integration with services, we will have obviously some form of service in our web application. So let me just make a couple of copies of it. So service 1, service 2, and let's imagine service 3. These 3 services might be as much internal as much external services to your web application. And since I'm talking about integration with third-party services, let's assume we are integrating with SendGrid by sending email. So our web application is gonna post a message to the queue, and either it or another async processor is gonna pick up that specific message and then send it over to the external service. You can increase over here the resiliency, for example, by adding some form of outbox and inbox. So essentially your web application is not gonna post directly to the queue. It's gonna store that message in the database and push it a little bit later into that specific queue, thus guaranteeing at least once delivery. And the async processor is going to make use of the inbox to essentially guarantee at most once delivery message, thus offering you some additional resiliency to the overall integration with the third-party service. And by the way, this is asynchronous integration. Your web application might also integrate synchronously with an external service. And in here, since this external service might be down for a specific period of time, and for example, a retry policy might help you increase the overall resiliency in your communication with the external party. We have a lot of stuff over here, and the next component that I want to take a look is to add some form of logging to the web application. By the way, you can decide to add logging way earlier. I'm just covering this part right now. Over here, I'm gonna have to add a log component, and essentially our web application is gonna push logs to this log aggregation solution. By the way, besides logs, you might also want to add a matrix aggregation or scrapper, and the most popular one that I've worked with was Prometheus and Grafana. So essentially your application is gonna provide data for the matrix aggregation, and over here you're gonna set up a dashboard that you're gonna use to view the logs, view the metrics, set up alerting and all that stuff. So essentially from the alerting dashboard, if you're using Grafana, you can send notifications to your notification channels just like the watchdog does. And in a more complex scenario, you might not even need this watchdog over here and do the monitoring from the dashboard and set up alarms in here. By the way, if we're talking about Prometheus, this arrow isn't really right. It should be the other way around into the web application, since Prometheus will use the scrape endpoints for collecting metrics data. Another use case that you might encounter in here might be, for example, to add some full text search capabilities. So it's full text search. More often than not, this full text search is gonna be Elasticsearch that you are gonna provide it with data from the database itself. Your web application is gonna search for data inside the full text search, and if required, store it inside a cache if you frequently access that data. A topic that we need to touch right now, before I forget about it, is the topic of authentication and authorization. I cannot imagine any kind of modern web application that does not have a component that is responsible for the topics of authorization and authentication. This component is pretty reusable across different applications, and you can build a generic one, so most likely you will end up using something like Identity Server, Keycloak, Authentic, etc. There are plenty of tools out there. Okay, and now for the final cherry on top is gonna be a topic that I've encountered pretty recently, and that's event streaming. Your web application might end up generating a big chunk of different events, which you might decide to stream somewhere and essentially build dashboards on top. In the past, I've used Kafka a lot for event streaming. However, what we did there for building those set dashboards that I've mentioned before was to offload the data from Kafka into a data storage. After receiving the events, would push the data to a data storage, and then we would have a dashboard built on top of that specific data storage. So essentially our dashboard application was integrating with this data storage and pulling data from there in order to present the fancy dashboards for the business. With that said, that's the end of the video, and I just wanted to raise your attention to take everything said here with a grain of salt, because not every web application will need all these components that I've shown you over here. Not every application will need event streaming capabilities, config services, full text search, async processing, notification channels, etc. It's all up to you to decide based on your constraints. Now, also, I haven't touched really much on the topic of how you're gonna deploy everything set in here. Will it be Kubernetes? Will it be cloud native services? Will it be virtual machines and on premises, and run everything in here on-prem? You should analyze your own constraints, your own technologies that you're using, since I try to do this as technology agnostic as possible, with some inclinations to the .NET world where I live in. So yeah, take everything with a grain of salt, pick whatever works best for you, and be critical in your thinking. That's the 3 best advice that I can give to you. And yeah, that's the end of the video. And I've touched on all the topics that I wanted to cover in here. And a bit of shameless self-promotion. If you're looking for learning in depth how you can build a .NET Core based modular monolithic application with a lot of topics from here, just going in depth, not just overview, I have a course available at vasiliolenic.com where I go over the topic of how you can build microservices ready architectures and microservices ready systems that you can deploy first as a monolith and then gradually evolve them into a set of microservices. If you like this kind of content, subscribe to the channel, click the notification bell, like a video, reshare, it helps a lot. And see you next time.